This is a video for lesson number 4, Inscribed Angles and Polygons. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So this, an inscribed angle, is this angle. The sides are chords and the vertex is on the circle. So angle Q is an inscribed angle. The measure of an inscribed angle is half the measure of the intercepted arc. That little bit right there is the main lesson today. You'll be surprised at how many geometry questions we can get out of that, but the measure of an inscribed angle is equal to half the measure of the intercepted arc. So if I tell you that, say, the measure of this arc, RP, is 140 degrees, then you know that the measure of the intercepted arc is half of that. So half of 140 degrees is 70 degrees. So that means that this angle has to be 70 degrees. And I'm getting that by saying that the measure of angle Q is equal to half of the 140 degrees, which is the arc, and then that gets me 70, which is the angle. So the reason that that can get a little bit confusing is because angle O is what we called from a couple lessons ago, maybe just the last lesson, the central angle. And RP is the intercepted arc. And we learned in the last lesson how to find the measure of the central angle compared to the arc. And the measure of the central angle in this case is this, well, the measure of the central angle is always equal to the measure of the intercepted arc. So in this case, angle ROP would also be 140 degrees. Not sure where to write that. And so basically you end up having to decide between using your given information, whether the two angles are equal or whether the two angles are half of each other. Sometimes you might be given the 70 degrees and need to find the 140. Sometimes you might be given the 140 as the central angle. Then you need to know that the arc is 140 and that the inscribed angle is 70 degrees. So angle Q is the inscribed angle and angle O is the central angle. Notice they end up being half of each other. One other bit of vocabulary for this section is that a polygon is inscribed in a circle if all of its vertices lie on the circle. So those are the vertices, and there's the circle, and that polygon is inscribed in the circle because all of its vertices lie on the circle. All right, we're going to work through these examples. It would be a good idea for you to pause the video and try some of them on your own if you're feeling confident, and if not, you can just follow along, but try to keep your brain engaged and pause it once you get it going if you think that you can do it, or maybe rewatch it and try the notes again after we've done them once through to see if you can do it on your own. All right, so in this case, I'm told that the intercepted arc is 156 degrees, and I want to know what the measure of this angle is. So in order to figure out what this angle is, I know that the inscribed angle is equal to half of the intercepted arc. So I'm just going to take half of 156, and that will tell me what the measure of the angle is. So grab your calculator, be active, or maybe you can do that one in your head, I hope. So this angle is 78 degrees because half of 56 is 78. Moving on to the next one. In this case, we're given that the inscribed angle is 55 degrees. And we want to know what the measure of the intercepted arc is. So if this angle is 55 degrees, then the intercepted arc must be double that. The angle is smaller than the arc. The inscribed angle is equal to half of the intercepted arc. So if this angle is 55 degrees, then this arc must be 110 degrees. All right, and then this concept this problem has both the concepts in it. So if the central angle is 122 degrees, then the intercepted arc is equal to that. That's not today's lesson, that's from a couple days ago. And then if you have 122 degrees on the intercepted arc, then the angle here is equal to half of that. So we could say that x is equal to half of 122, or x equals 61. All right, so that's the basics of this chapter, or this section. And then there's just some situations that come up that sometimes students find a little tricky. So if on number 2 here, we have the measure of arc EA is equal to 94. So I'm going to label that. As 94 degrees. Then the measure of angle B that is intercepting that has to be half of 94. So half of 94 is 47 degrees. And the measure of angle N, which is also intercepting the same arc, is also 47 degrees. So there's a theorem that says that if two inscribed angles intercept the same arc, then the angles are congruent. So if two inscribed angles intercept the same arc, then the angles are congruent. So even if I hadn't been given this 94 degrees here, I would still know that these two angles have to be congruent because they are intercepting the same arc from E to A. All right, moving on to the next one. If RO is a diameter of a circle, that's kind of like an inscribed angle, then the measure of arc RO has to be 180 degrees. And so then the measure of angle C, since it's intercepting an arc that is 180 degrees, this angle has to be half of 180 degrees, so it is 90 degrees. Therefore, triangle COR is a right triangle. And a theorem is a right triangle is inscribed in a circle if and only if the hypotenuse is a diameter of the circle. All right, moving over to the second page. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So that means that the measure of angle F plus the measure of angle D has to equal 180 degrees. And also the measure of angle E plus the measure of angle G also equals 180 degrees. We'll kind of see a reason why this is true in this last example over here. So hang on to that for just a second. All right, looking at this problem here, number 5, find the value of each variable in the indicated arc measures. So the thing that jumps out at me here is that that line is a diameter. So if this is a straight line that goes through the center of the circle, then it's a central angle that's 180 degrees, which means that this is a semicircle. Central angle and intercepted arc are equal, and a semicircle is 180 degrees. So then this intercepted arc must be half of that, or 90 degrees. And then if this is 90, then all three of these have to add up to 180, so angle Y would have to be 50 degrees. And then if I know that this is 50 degrees, then I know that the intercepted arc across from that isn't the same size as this. Remember, these two are related by half. So if the angle is 50, then the arc would be 100 degrees. And then if we have angle M, arc KM, we already know is 180 degrees. I think I probably meant to ask about arc LK, which would have to be double the 40 degree angle. I need a new color, I guess. Use red. This one must be 80 degrees because it has to be double the 40-degree angle. So then this one would be 80 degrees, and you could double check to see that 100 plus 80 plus 180 gives you 360 all the way around the circle, and 40 plus 50 plus 90 gives you 180 for the angles in the circle. In the triangle. So 180 degrees in the triangle and 360 degrees in the arc around the circle. All right, so in finding this one, the angle X and D have to add up to 180 degrees. So angle X must be 98 degrees. And 68 and Y have to add up to 180 degrees, so this one must be 112 degrees. And arc BCD, so let's see, this one is 98, and this one is 112, and arc BCD is that arc which has to be double 112, or 224, and arc BD would be this one, and that has to be double 68, or 136. I'm going to end it there because I think my video might be out of time.